Hello, good morning, good afternoon, wherever you are in the country. My name is Silas Nichols, and I'm with the FHWA Office of Bridges and Structures in Washington, D.C. And let me be the first to welcome you to this 2020 Winter Webinar Series. This is the second half kickoff for Every Day Counts 5 Innovation Advanced Geotechnical Methods for Exploration, or as you all know it, the A-GaME. I recognize that second half kickoff is a football reference, and I should probably have a whistle or some sort of stadium horn or something like that, but we're just gonna have to make do with what we have. So, let's go. So this will be the first webinar in the Winter Webinar Series, intended to advance the FHWA implementation efforts for underutilized site investigation tools to improve site characterization programs and to better identify and address risks that may come up in project delivery. This first webinar, we're intending to give you an update on where we are with implementation efforts, demonstrate how the A-GaME can add value for your organization, provide success stories from some of the select states that are champions in the A-GaME, and to preview the rest of the Winter Webinar Series. We got a lot of content to get to, short amount of time, so I'm gonna get out of the way here. Our speakers are on the screen currently. Ben Rivers and Derrick Dasenbrock, both from the FHWA Resource Center, are going to lead you through this. And with no further ado, I'm going to turn this over to Ben Rivers. Please keep in mind, use the chat feature to throw your questions in, and we'll get to those at the end of the presentations. Ben?
Thank you very much, Silas. I'm going to share my screen here. And get it into presentation mode. There we go. All right, welcome everybody. Welcome back to the second half of the A-GaME rollout. Some of you may be very familiar with the A-GaME, and this may just be a refresher for you. Others, this may be the first time that you've seen or been exposed to the A-GaME. The bottom line here is that we recognize that we can do better in our subsurface investigation and site characterization efforts. And that's what the A-GaME is about. It is about removing uncertainties, unnecessary uncertainties upfront. Investing upfront in our subsurface investigation so that we remove or reduce the chances of bad things happening during construction in terms of delays and cost escalations. There we go. So the front and center, certainly our site investigators and our geotechnical service providers, geophysical service providers have a star role in characterizing our conditions for projects. But we are not the only players in this game. We have contractors, designers, project managers, construction managers, and other decision makers that are instrumental into making decisions on how we are able to invest and get the information that we need for site characterization. Obviously for design, the reliability of the parameters that we get, the constructability of the sites for the complexities that we may run into for various construction projects have a big part. And so all of these players have a vested interest in getting the information that we need for our projects. Owners and decision makers have the ability to provide us the funds that are necessary, and that also the contracting methods that are involved in our contracting delivery methods obviously have a part to play in understanding how we provide those funds up front or make provisions for the project delivery method is key for that. So what we're dealing with, the playing field, obviously every project has project objectives that define the intent, the function, the aesthetics, the performance expectations of those facilities, and our conditions that Mother Nature provides us is going to play a part in what solutions we have for coming up with feasible designs and constructible designs, and taking in consideration what are the cost benefit considerations, especially when we're looking at project objectives that may be putting speed of construction up front, or do we have time to allow consolidation to take place, or other methods that we have that may take more time in more traditional solutions, but we need to look at all options. And so we need to understand what those project objectives are so that we can get the information that we need during our site investigation. And of course, the geotechnical complexities, the project complexities, are we doing complex interchange? Do we have considerable load demands? Those certainly are project considerations. The complexities could be, as you're seeing in the picture here, where we have karst terrain and pinnacle and cutter type formations, or the materials that we're dealing with in construction are they, how hard is it to excavate through these materials and construct our facility? So all of these sort of define our playing field. Where are these risks that we are trying to avoid? This information comes from a synthesis called NCHRP Synthesis 484, the influence of geotechnical investigation and subsurface conditions on claims change orders and cost overruns. These are probably very familiar to most of you out there in cyberspace. Overruns in materials. Groundwater has always been very impactful in any geotechnical construction effort that we do, and they were certainly cited in this report as in two methods here: higher than expected groundwater conditions, seepage, and other requirements that contractors need to be aware of for dewatering. Those things being surprises can be quite costly. And when we get into mischaracterizing materials or not characterizing those at all, missing them completely when we get out in the field and we break ground, if we're getting into conditions where we have to remove and replace excessively, or decide if we need to go back to the drawing board and do ground improvement or other design redos, that certainly is going to impact our time schedule and cost for our projects. Unanticipated rock in foundation construction and in drilled shaft construction certainly has a big part to play as well. So all of these were identified as very common problems, sources of delays and cost escalations. Very recently, in fact, somebody pointed this out to me just a few weeks ago. Yobasaki from UC Davis provided well, it's based on her work while she was at UC Davis, but it was published in the Geo Congress last spring. Did a report where she was looking at claims that were reported to geotechnical companies or against geotechnical companies. And there were, I think, 1,500 cases that she reviewed. Of those 1,500, about 900 she analyzed closely because they were significant. And if you just look at the data that she provided, this is very consistent with what we found in our synthesis 484, where we knew that up to 50% of all change orders, claims, cost overruns were due to geotechnical issues. This is that subset of data that are geotechnical issues. And within that subset, you're seeing that 44% of those claims were directly related to the quality and the scope of geotechnical investigation. And then we also recognize, and this is consistent with what was found in the synthesis 484, that indirect claims, change orders, cost overruns were related. In this case, these are claims that were related to foundations, grading, were indirectly related to the subsurface investigation quality and scope. And a significant amount of those indirect claims have a huge part, dollar amount wise, when we're looking at all of the influences that are directly or indirectly related to the quality and scope of our subsurface characterization. This is one of my favorite graphs. It comes from synthesis 484-2. On the y-axis, you can see cost escalation, and on the x-axis, you can see the cost of our subsurface investigation. And you can see an obvious relationship between the two. In transportation, typically, we spend about 1% to 3% of our project budget on site characterization. Imagine if we were wise about how we spent that 1% to 3%. And imagine that when the risks are there, where we can ask for additional funds, where it's warranted, we can significantly reduce the likelihood of bad things happening during construction. The strategy, and this is consistent actually with what Yabasaki came up with as well as recommendations. The strategy first and foremost is to be smart about how we do our subsurface investigations. So using a rational approach and not using an ad hoc or prescriptive basis for applying minimum standards and requirements. We want to be thoughtful in what type of information is going to provide the most value for us. Using effective, underutilized investigation methods that, we have more tools in our toolbox than the standard penetration test. And many of those technologies have been around for a long time, but they remain underutilized. And so looking explicitly at what types of methods can help us characterize and get the information that we need is part of that strategy. The communication, obviously, we have a part, as far as geotechnical engineering, have a part in interpreting the subsurface conditions, coming up with that model that explains variability and the parameters that we use in design and how easy or hard it is for us to construct in those materials. We don't only have to come up with that, but we have to communicate that. And that's can be, if we're just throwing it into project plans, there's an argument to be made that that's maybe not the best way of communicating and making sure everybody's on the same page. And we can improve that communication. And we have ways of doing that, and we'll explain how things are moving toward improving that communication. And also having a feedback loop to those other stakeholders and understanding what information is valuable for them for specific projects and requirements. That was one thing explicitly that Yabasaki also pointed out and has in a similar flowchart that you see here. This flowchart comes from the 2002 GEC5 manual, the original GEC5, and I've broken up this flowchart into two parts so that you can see them. This first and foremost starts with defining what we, or understanding the conditions, coming up with a preliminary model that that we have the ability to come up with our experience with certain regions, conditions, understanding where we can find information from the web, Google Earth, USGS, a whole bunch of information that we can gain before we even start getting out into the field. We can come up with our preconceived notion of what subsurface conditions we anticipate. And that's key in this rational process. We anticipate what we're expecting. We scope our subsurface investigations accordingly. And there's a point at which, and I think this is a very important concept that came up during one of our workshops, A-GaME workshops. If we take a moment just to stop at this point and look at our risks and look at our project requirements and information that we need for our designs and construction, if we stop at this point and we think about what type of what we need to focus on as far as variability and parameters, design parameters, if we stop at this point and make an argument to those decision makers that perhaps we need more than those minimum requirements, that we can make an argument to do more, to invest more in that subsurface investigation program. And as we go along here, as we find out more information, we have a number of checks where we're going to see if that preliminary model makes sense and redefine that model continuously as we go through this process. Reviewing those design objectives and getting into the laboratory testing programs, seeing if the results that we're getting are consistent with what we anticipate, and if we need to do a phase 2 program. Ultimately, what we're looking for is making sure at the end of the day that we have the information that we need for design and constructability considerations. So, technologies that we're looking at with the A-GaME, the game changers. If you look here, you can see technologies that are bold. These are considered the featured A-GaME technologies. They're not the only methods out there that the A-GaME is promoting. These are the featured methods because they are most commonly the most effective in general conditions that we have in the US. There are a number of other technologies that you see here, GPR, pressure meter, dilatometer. All of these technologies may be the right tool for our job, and the A-GaME does not preclude using those. We're just featuring these methods because if we can get these technologies into practice, we'll be doing well. And what the colorations here suggest are the different families of technologies that we're promoting or showcasing within the A-GaME: CPT, co-penetration tests, electrical geophysical methods, seismic geophysical methods, acoustic and optical televiewer, and measurement while drilling are those featured technologies. If we get these into practice, we'll be doing well. Many of you are familiar with the co-penetration test. It is not a new test. but it remains underutilized. Cone penetration tests are, if we can be pushing cones into the ground, we probably should, because they're more reliable than traditional and conventional standard penetration tests. In index values, we can actually see variations as we get through the ground and distinguish where those changes occur. We can get pore water pressure measurements that are fundamental to geotechnical engineering and effective stress. So how well we characterize effective stress and how well we characterize groundwater conditions, as you remember, being one of the major contributors to problems in construction, the better we can do. And traditionally, we have not done a great job characterizing groundwater conditions and their influence on our, both on the constructability and on the design side. Shear wave measurements can be captured with an additional contraption or instrumentation on a cone penetration cone, so that we can actually see shear wave velocities or capture that data, as well as the other data, cone penetration or the tip resistance, skin friction, pore water pressure, and then the friction ratio that you see here that can distinguish behaviorally what those materials might be. But specifically, we can see those values and have a more reliable measure for design. This cone penetration test is 3 to 10 times as fast as conventional drilling, which adds a lot to for this method. And its safety is something that I didn't list here, but it's been mentioned quite often. We're not around spinning equipment. In this case, we have a safer environment to get these measures. Mainstreaming electrical methods, and this includes electrical resistivity, induced polarization, self-potential. In all cases, and this is true for all geophysical methods, the more contrast we have with whatever measurement that we're looking at, we're trying to relate that to something that's meaningful in geotechnical engineering. And many of these actually do that very well. If we're looking for differences in resistivity or conductivity, contrasting materials such as clay that are very conductive versus sands that are resistive, voids infinitely resistive, groundwater that is more conductive. The more contrast we have in our profiles, and when we're targeting specific conditions, in this case, it was targeting a void that showed up very well in this profile as this pink, highly resistive area. So we can distinguish different materials within the stratigraphy over a long area and see the variability that we have across a site that we don't traditionally get with a point-specific measure like standard penetration borings or even cone penetration tests. So this, in addition to in situ methods that we can get those parameters that we need, these can be correlated to show the variations of materials that we have in our subsurface. A new technology to us in the US, not to Europe, is measurement while drilling. And of course, actually measurement while drilling has been around in the US for quality assurance purposes for drilled foundations. We're talking about looking at measurement while drilling specifically for geotechnical investigation purposes here. And we get, of course, same technology. What we're looking at is instrumenting our drill rigs, and it is standardized for rotary methods in Europe for where we instrument drill rigs for rotation speed, crowd, torque, fluid pressure, penetration, all with respect to time. We're able to, very similar to the cone penetration tests, to discern different materials within this, the subsurface. And we can actually even drill in rock where we wouldn't be able to push a cone in this case. So we can discern materials, we get a continuous profile. This is typically data that a driller would be marking on the boring log, saying that we have chatter at, from 3 to 8 feet. We can actually see that in the data that we're gathering when we're using measurement while drilling instrumented drill rigs. Very useful technology, and I think has a lot of potential for subsurface investigations. We'll hear more about that in a bit with some of the, with Montana's talk. Seismic methods, geophysical methods, again, we can distinguish material differences across a large area, identify where those boundaries are between contrasting materials, as long as we have that contrast and we can relate that to something significant for geotechnical purposes. These are quite valuable to us. We can also measure directly wave speed that can be related to modulus, shear strain modulus that at very, very small strains that define sort of the initial behavior of displacements for us. And we can also distinguish or help characterize seismic hazard susceptibility and liquefaction with these methods using wave speed. Acoustic and optical televiewers. This technology has been around quite a bit for a long time, but really picking up speed, and people are understanding the value. You're seeing a probe here, or part of a probe anyway. It's quite 8 to 10 foot probe, and you're seeing the instrumentation at the tip here, in this case an optical televiewer with centralizers here that once we go do coring, or we have a core hole, we can put this probe into the ground and get measurements continuously as we're coming up high quality, high resolution, 360-degree spatially oriented data, continuous. We can get data for the in-place rock structure. In the past, where we've tried before this technology, when we're looking for oriented coring, that's quite a difficult operation, and this certainly takes the place of this by providing the same data that we would get spatially oriented. And it also is independent of the core quality. So if we're not getting great core recovery and samples back, this certainly can show us what the in-place conditions are that the core is not telling us. So a great valuable technology, especially when we're looking at the condition of rock quality and conditions, structural geology. What you're seeing here is sort of a sinusoidal wave of an open joint. And if you imagine wrapping this, you're seeing 0 degrees to 360 degrees, which is the entire circumference of that image. If you wrap that, you could imagine that you have a dip in dip direction that's given by these discontinuities, and you can see significant structure here that may be valuable for those our designs, and you can get the statistics and joint sets represented in stereo nets and other features here. Ultimately, what we're looking at to do is do better in our subsurface investigations, improve current practice by reducing risks, removing those uncertainties by being smart about our subsurface investigation and applying methods that are most appropriate for getting the information that's going to describe the parameters that we need for design and the variability that we have in both design and construction. The quality can help provide reliability for our designs, and by preventing those problems happening during construction, we can more readily accelerate project delivery or prevent those bad things from happening and keeping projects on track and on time and on budget. So that is the A-game. If we take a look at the future on what's coming, some of you may be familiar with a digital exchange for geotechnical data, a schema known as DIGS that's very similar to the AGS system in United Kingdom. It's been in the works for 20 years or so, but most recently, AASHTO has put out a provisional standard of practice to incorporate that schema in our practice. In any time that we're transferring data or we're exchanging data within systems, this concept, the schema known as DIGS, is going to be quite revolutionary in improving processes, improving the way we can actually manage data. And what you're seeing down here at the bottom is actually a recent example of that, where data in the DIGS format was easily pulled because they anticipate the structure of the data coming in, very similar to a website where you would use HTML. The structure is the same. So the data that's pulled in to this application, which is a web app from Louisiana DOTD, they're able to assess the data, whatever data they capture and are wanting to analyze for the statistics of, in terms of variability or the values and how they change within the subsurface. So this is, imagine processes that used to take weeks, even months, can happen in a fraction of that time, in days of time. So quite revolutionary in improving the processes. And imagine just if everybody's using it and they're capturing it from data acquisition to the point at which we're analyzing it, it can be extremely beneficial. Similarly, we in this digital age, and that's sort of the benefit of some of these technology, all of the technologies that we're talking about with the A-GaME, they are digitally acquired. So using a system like DIGS would allow us to transfer data into a system like what you're seeing here, where we can visualize data in in this case, a holographic space. And this is, we've been using the HoloLens to showcase some of the A-GaME technologies. We're finding that it is an incredible communication tool, especially for those who are not geotechnical engineers. You can see immediately those aspects that we're talking about, changes in the subsurface profile. So this, I think, is a glimpse into the future on how technologies like this can help us communicate to not just the geotechnical engineers, but other stakeholders that have interest in the quality of our data. Something also, if we're looking at DIGS and take a look at geotechnical data management certainly is a topic of interest. Not just that, but geotechnical asset management, data that is acquired and used or conveyed using digs can really revolutionize all of these elements: communication, data fusion, machine learning, and the reliability, just doing calibrations within the parameters that we get for design. This has a revolutionary aspect to how we do business. Likewise, this e-construction and digital as-built is an EDC 6 initiative that's coming out, and the DIGS application has great crossover with those with that effort, and we hope to have that opportunity to communicate with our construction partners and how DIGS can be integrated into their systems. So with that, that is just an overview of what the A-GaME's about. Welcome back, and a glimpse into the future where we're headed. And that is the end of my presentation. We're going to transition over to Derrick. I'm going to just remind everybody as Derrick cues up his presentation that please use the chat pod to populate your questions or comments for us, and we will, at the end of this presentation or webinar, get back to you on those.
Derrick, you're on mute.
All right, turns out when I share my screen, things change around, so it's difficult to find the unmute button. So back to the screen share. Okay, it's only been 6 months or so of doing virtual presentations, and I've almost learned how to do this. Afternoon, everybody. My name is Derrick Dasenbrock, a colleague of Ben Rivers working in the Federal Highways Research Center, and it's a pleasure to be talking with you this afternoon about what's in store after our halftime show here with the second half of the A-GaME. So today is webinar 1 of 10 of what we're calling our winter webinar series. So it will have sort of by implication of 10 webinars, 9 additional ones. They'll be occurring weekly at the same time on Tuesdays. So our next webinar is November 24th. We'll be sending out the registration for that webinar shortly after today's. And it's going to be on the topic of selecting the right tools for the job and achieving project design and constructability objectives. It'll be a great session. We have 2 invited speakers, Jerry DiMaggio talking about geotechnical fundamentals, and Eric Lohr, who'll be discussing risk and site variability. And following those 2 presentations, we'll be heading into a panel discussion where we will have representatives from 5 departments of transportation: California, Washington, North Carolina, Minnesota, and New Hampshire, to talk about some of their state experiences in how to select the right geotechnical tools out of the A-GaME portfolio and additional tools for geotechnical projects. After that, the next session will be on contracting and how to assemble your A-GaME team. On December 8th, we'll be having a session about outcomes and how to win the A-GaME, and that'll be part of a larger event, which I'll get to shortly, EDC 6 Virtual Summit. Following that, we'll be highlighting each of the 4 areas of the A-GaME targeted technologies. Geophysics, that'll be an extra long session on the 15th, then CPT testing, measurement while drilling, televiewers, and then a webinar in early February on processing and analysis of the data. And then the final webinar of the series will be about reporting and visualization, geotechnical asset management and data management, and essentially winning the A-GaME. So I'm looking forward to the entire series, and I hope everybody will be able to make it on Tuesday afternoons. The webinars following this one will be recorded, so even if you miss one, you'll be able to view it at a later time. The Everyday Counts 6 virtual summit has also invited Everyday Counts project and programs from EDC 4 and 5 to partner as part of a virtual summit for 3 days, December 8th through 10th. We're participating in what's called the Virtual A-GaME Pavilion at that summit. There will be videos, PDFs of the information that we have on a number of project case histories, and a lot of reference and resources that we're assembling for that booth. It'll be manned for about 2 hours on each day, where either Ben or I or other individuals will be in the room and available to answer questions that you might have about the A-GaME or a particular project, maybe if you have an interest in applying A-GaME tools. As far as the event program, I certainly encourage you to take a look at what EDC 6 has on offer. Ben mentioned that a little bit in his discussions. The one area that's particularly well suited to be a collaborative effort with our EDC 5 A-GaME is going to be the digital as-built area. We're looking at already some partnering ideas with EDC 6 in terms of providing digital information through digs and through the information that's gained in the site investigation phase of a project, and making that a more permanent record, as well as the as-built construction for projects. So we're excited to already have some discussions with our EDC 6 colleagues. So we hope you can join us for those events coming up in early December. So an update on upcoming virtual offerings that we're going to be rolling out later this year and then in 2021. We've been working on converting a lot of these into the virtual space. So as part of the A-GaME, we're going to be continuing to offer training. States had requested that, and it's in our database of A-GaME requests, as well as technical support with specific projects, which we've been offering since the start of the program. We've been working on guidance documents and example applications, webinar trainings that are tailored to specific topics, and then workshops which are not only targeted to the geotechnical discipline, but also our partner areas of design and construction. And one thing that we're also actively working on are peer exchanges. There's going to be one in the middle of December, specifically targeted to our states that have expressed interest in measurement while drilling. That'll be the first large virtual peer exchange on an A-GaME topic, and we're hoping to have more of those in early 2021. We've been also working on a variety of facilitated discussions using different platforms, phone calls, video platforms like today, web-based training, and we're also working on getting case studies together to help states in their A-GaME implementation. One thing that we have been actively doing over the summer is exploring more collaboration opportunities and partnering events. We've been doing a lot of outreach to our colleagues at the Transportation Research Board, the ASCE Geo Institute, the Deep Foundations Institute, and others. We have a lot of partnering going on at the annual meetings. For those of you that were at the Deep Foundations Institute 45th virtual meeting, A-GaME was a significant part of the technical program for that meeting. So big shout out to all the people that presented and discussed the A-GaME initiatives as part of that meeting. We've also been working on getting A-GaME and the technologies onto the schedule and into committee meeting discussions and dialogue. And it's also now an integral part of a number of workshops and invited speaker sessions and technical presentations. So we've been working with industry groups and essentially taking the A-GaME to the next step, where it's no longer simply an EDC5 initiative, but it's more integrated into the geotechnical engineering just mindset. Let's see, so user groups. This is a new thing that we're working on at the moment. We're looking at establishing partnerships with the Geo Institute, DFI, and TRB, and a number of the committees that are associated with those groups. There is currently a cone penetration users group. Dr. Nazir Abluhejla with Federal Highways is a member of the GI's Shallow Foundations Committee and TRB Committee. He's been working with the CPT users group for a number of years now, and we're looking at continuing that. And certainly if you have any ideas for that, as far as additional speakers and topics, we always welcome participation there, and we're hoping to make that have more regular meetings. And we're also looking at establishing a similar type of users group for exploration geophysics and televiewers, and another one for measurement while drilling, as both of those are technologies that we're also interested in getting more collaboration on as we move forward. With that, I would like to move into our next session as part of today. So this is what we called our lightning round. So 10 states responded to a call for an opportunity to present what they've been working on as part of the A-GaME. And they have prepared short 3-minute presentations where they're going to be now able to discuss with you the highlights of things that they've been doing in their own states. So I'm looking forward to seeing those, because there's been a lot of really great progress on the state level. And with that, I will stop the screen share here, and we'll roll the videos.
Hi, my name is David Thomas. I'm with the Colorado Department of Transportation, Soils, and Geotechnical Services. I'd like to take a minute or two just to talk to you about our experience with A-GaME. At CDOT, we try to use geophysics where we can. We find that it's really quick, get a lot of information for a reduced cost. Also, if we do traditional drilling, we're going to impact traffic. So geophysics, it goes a lot quicker than having a drill rig out there for 2 or 3 days. In this case, we use S-wave and resistivity to analyze a subsurface where we thought there was a void. It turned out it was soft soils and not a void, so we were able to actually address that issue properly. We also use GPR, or ground penetrating radar. We use this mostly on pavement distress analysis or to find buried or lost culverts. In this scenario, we had some pavement distress, and we thought it was actually from settling soils and we have void under the highway, but it turned out to be a slope stability issue. And this helped us to quickly analyze it and address the issue properly. We're trying to get more CPT, or cone penetration testing, in Colorado. It doesn't really work in our rocky mountainous terrains, but on the eastern plains and on the western slope where there's thick clay deposits, we found we can get a lot of data really quickly. We've also used this in conjunction with scour testing for hydraulics, and this helps us to get a lot of data for the scour testing so we can focus where our drill rig is going to be and take samples. What we want to do in the future is also incorporate augmented reality. It's really neat. It's a great function. You can see a lot of data in 3 dimensions, present it to stakeholders so they can easily digest the information. The only problem is the cost. The headsets are a cost, the data development's a cost, the modeling's a cost. So is it better to purchase these items or just have a consultant provide these items at a set cost? So some of the challenges and solutions we've faced, it's marketing and education. You need to meet with designers, let them know these other aspects and these other things are out there. Also, project involvement and timing. We need to ask for the project list so we can be upfront on those projects and where we can apply the A-GaME technology and help save projects money and time. Also, the project schedule and needs. Does it even apply to the project? Is it going to be useful or just another tool that is never applied to the project? And then funding. Who's going to pay for it? Right now, we're looking for grants. We're begging, we're pleading, we're trying to find any way for the project to help use these new tools to show them the money up front is a cost saving at the end.
Alaska Department of Transportation and Public Facilities has used geophysics on a project-specific basis for years. But when the Everyday Counts 5 A-GaME initiative came out, we recognized that geophysics could enhance our in-house drilling program. We procured capacitively coupled resistivity and ground-penetrating radar equipment and hired an Alaskan geophysical expert who we had worked with in the past to train us on those techniques and on Alaska-specific applications. Our primary goal was locating ice-rich permafrost and massive ice. Those are the biggest geotechnical hazards in our region. We found that using the GPR to locate poorly mapped utilities has allowed us to drill safely in places where we otherwise couldn't. And we've used GPR numerous times to investigate local failures for our maintenance and operation folks. Things like locating sinkhole or identifying sinkholes and mapping underground slide surfaces. And we use a high-frequency antenna with our GPR to measure the thickness of heavily patched asphalt. Due to our poor foundation conditions, we have places where the asphalt patching is on the order of several feet thick. Our geologists collect geophysical data while the drill is moving between holes or while it's being serviced, so there's very little extra time added to our program. Since we can see real-time results, identifying anomalies, we know where to drill, so we're getting more complete borehole data with fewer holes than if we were drilling at a set spacing. Plus, we're filling in the gaps between the holes. In turn, the borings help us calibrate the geophysical data back in the office, and they confirm what those anomalies actually are. Alaska has many communities that are off the road system, so mobilizing a drill rig is a huge commitment and expense. So for recon work, we start with geophysics, which fits in some large Pelican cases and can be flown in small aircraft into villages. Sometimes a geophysical investigation is all we do, although it's always best to ground truth and calibrate the data with drilling. It's really difficult to quantify the cost and time savings that geophysics has brought to our investigations. Every program is unique, so we can't really compare a with geophysics to without geophysics cost comparison. It's really more about getting much better and more complete data and better results by drilling smarter than it is about saving money. On the other hand, to get the same quality of data that we're getting now by combining geophysics with drilling, we would have had to drill many, many more holes, so clearly there's a huge cost savings.
Hi, my name is Lydia Brownell, and I'm a geotechnical engineer with the Missouri Department of Transportation. Our office has limited CPT users. We currently have 2 very knowledgeable CPT folks, and the rest of us are learning as we go. To help train others in the field with the use of our CPT rig, we created detailed field guidance instructions specific to our equipment. These instructions begin with preparing the filter ring to cable connections on the rig to software setup and procedures on the laptop. We have also created CPT2 and CLIC2 software instructions to assist with data analysis. We don't use the CPT on a regular basis, so these items have helped with data analysis. MoDOT's geotechnical section is continuing research to correlate NKT factors to laboratory undrained shear strength and SPT values. Due to COVID-19, we have been unable to travel, so our sites are limited to nearby locations. The current research involves 3 sites: a typical clay over shale in northeast Missouri, a clay silt overlying deep sands near the Missouri River bottoms, and a site with deep fat clays near the Gasconade River. Our plan is to develop a site calibration process to allow more frequent use of the CPT on projects with proposed piles or settlement concerns. Our former director had begun these calculations just before his retirement. Unfortunately, time has not allowed for reviewing his work, but we are about to pick that back up again. We are also beginning to use the CPT to estimate total settlement and settlement rate on smaller projects to look at their accuracy and effectiveness with respect to actual measured results. This involves increased time constraints for dissipation testing with the CPT, as we do not have an enclosed system we can leave on site. We are awaiting feedback for the project pictured. This project consisted of reducing the bridge length by half its length and will consist of approximately 15 to 20 foot fills at the Grand River overflow. Construction should begin very soon. Just recently, we have seen an increase in pile overruns during this construction season. While reviewing past projects, we have noticed very high fee angles within our CPT data compared to typical fee angles calculated using the effective overburden correction of N values in sand when using equation 5-2 and table 5-5 modified after Bowles 1997 in GEC 12. We are beginning to look at our CPT values and determine if a correction is needed in our CPT calculations. We are also trying to compare the static pile capacity derived from our CPT data during design and PDA CapWAP pile capacity data obtained during construction. We are continuing to look for ways we can increase our CPT use, as time is always against us. Our biggest hurdle overall is knowledge of the CPT and analysis of the data we obtain.
This is Nick James, Geotechnical Engineer with Montana Department of Transportation. A summary of the work we've done to add mechanical torque measurement to the MWD system on our CME 1050 ATV drill rig. The slide here shows the sensors that were provided to us by Jean Lutz America and that have been installed on our rig. Unfortunately, no mechanical torque sensor is currently available with our system, so we've had to install two mechanical torque sensors on our rig. The first attempt was to use mechanical torque within the driveline. This is a schematic of the driveline of the 1050. The purpose was to provide a location that is out of the way but yet accessible and able to be used to monitor torque regardless of the drilling method used. The sensor was installed in the companion flange here between the transmission and the drive shaft. A new companion flange had to be manufactured. This is a picture of it, manufactured companion flange with the sensor on it. Benefits of this sensor location is it's easily accessible, the part is cheap and replaceable, and it can measure torque with any drilling method used. The downsides are the companion flange may be too stiff and possibly tone deaf to subtle changes in the torque. Torque losses between the sensor and the drill bit need to be accounted for, and there may be some signal loss between the wireless transmitter due to the sensor being protected. The second spot we put a sensor was at the API drill rod. The purpose was to provide torque measurements at the front end of the rig. API drill rod is manufactured by CME, and you can see it here. Benefits of the sensor being here is it's easily accessible, the losses across the rig are reduced, it provides higher resolution than the drive shaft sensor, and it can measure torque with multiple drilling methods. The drawbacks are the collar is too large to fit in the augers and needs to be removed every time the augers are being used. Part ID has to be machined down, which makes it a little bit weaker, although we haven't seen a problem with that. Real-time output, you can see from the laptop in the field, the drill rod sensors on the left and the drive shaft sensors on the right. As you can see, there's similar trends. However, there's less noise in the drill rod sensor than in the drive shaft sensor. So torque sensor communication, we've had some problems with the Torque Link 200 wireless system. They communicate wirelessly. The sensor communicates wirelessly with the gateway you can see here. However, we've noticed that the sensors have to remain on all the time in order for them to work properly, which burns the battery out. The battery has to be replaced every about 100 hours. The John Lutz system gets a continuous signal from the gateway, which is digital, and then the John Lutz system has to convert it back to analog, and then it converts it with a conversion factor, which we are working on with Jean Lutz. What's next? Next on our list is to get the companion flange repaired, and we may need to machine the ID a little bit and recalibrate it, and we're working on that this week. we need to consider maybe potentially instrumenting a 5-foot flightless auger or the power head adapter at some point, and we may need to consider wired system. Thank you for your attention.
Jennifer Rauch here. I'm the Assistant Geotechnical Engineer and A-GaME Co-Chair for MassDOT. I'll be your guide through the zoo that is MassDOT's A-GaME update. Before the rest of March was on Groundhog Day mode, we had a plan. It was a fabulous plan too. And then in mid-March, we were sent home, thankfully not for being on the naughty list. At the moment, the bulk of MassDOT staff have yet to return to our offices in downtown Boston and our district offices across the state. All our planned local workshops and initiatives went the way of the baby in the bathwater, down the drain. Like so many, we pivoted. We're like Marines. We adapted and we overcame. We got an offer from UMass Transportation Center to host our planned April workshop via webinar through them. It was the perfect opportunity to pivot. All we had to do was have the estimable Mary Nodine show up and wow our audience, and she was aces on October 1st. MassDOT's geotechnical section has historically deployed what are now known as A-GaME technologies, where they make sense for the state's subsurface conditions. We were the cool kids before the cool kids knew they were cool. Particularly, we've deployed CPTs and geophysical surveys at various projects. We've also deployed televiewers on design build projects. As MassDOT does not have drill rigs, we have not yet explored measurement while drilling. One of our A-GaME team members came up with an ingenious idea for a simple resource map to aid with navigating where the A-GaME technologies may work best across Massachusetts. We developed a draft paper map and an engineering directive, basically a how-to use this map guide, CPT for dummies. We got 10 feet from the finish line with getting this map and engineering directive in for review and approval and just ran out of gas. But as we've gone through our Groundhog Days teleworking from home this past summer, we are slowly crawling our way to getting back on track for some of our A-GaME objectives. As work between design projects and solving construction issues allows, we are plugging away at knocking some more A-GaME objectives off our to-do board, and even planning a few more to try and bite off and chew. Through MassDOT's Office of Planning and Research, the Geotechnical section has been awarded funding for a research project involving development of a overburden thickness and depth to bedrock map of Massachusetts. The technical terms of 2D raster image for GIS and VHSR is way above my head. I am the project champion for this research, and we have just recently selected a project investigator in Dr. Maybe. I'm super excited for this work, mostly because Dr. Maybe is super excited for it. It's a great opportunity nonetheless, and it also ties into our A-GaME initiatives, which is just a bonus. That's my day at the MassDOT Zoo. Thanks for coming.
Hello, I'm Aaron Poise, an engineer in the Geotechnical Services section at Michigan DOT. I'm here today to discuss our implementation of cone penetration testing as part of FHWA's EDC5 A-GaME initiative. MDOT procured our CPT equipment in late 2019, early 2020 with the help of State Transportation Innovation Council funds, STIC funds. Our CPT is a self-anchoring system with 20 tons of push force mounted on a skid steer, which provides us flexibility for site access while still providing enough push capacity. The CPT is equipped with 15 square centimeter seismic piezocones and operated by our statewide soil boring crew. MDOT started deploying CPT on select projects in late March 2020 and has pushed approximately 40 CPT soundings at 10 locations around the state to gain experience with the CPT equipment and the collected data. We have reached depths of up to 100 feet in softer clay or organic profiles. These sites cover not only a wide geographical range of Michigan, but our geologic conditions as well. At M66 over Monroe Creek, we pushed 4 CPTs prior to doing the SPT borings for this culvert replacement. The CPT provided a more detailed stratigraphy of a softer organic soil zone, and we were able to target this zone and collect samples when completing the SPT borings. With the improved stratigraphy and samples, we were able to change the culvert type and construction methods to benefit this project. MDOT is currently working on comparing the side-by-side data from the CPT, SPT, and laboratory testing. We are working through the difference between soil behavior type and soil classification, and are comparing CPT correlations to soil properties such as undrained shear strength, unit weight, and friction angle from laboratory testing. We anticipate working on completing side-by-side design with CPT and SPT data and determining how and what information to present with the CPT in our plan sets. We are setting up training for MDOT personnel to gain more experience with CPT, and then we'll incorporate our findings into a technology transfer with FHWA, our consultants, and local agencies. These trainings are partially funded with stick funds from FHWA. Initial lessons learned include that top-down support for CPT is beneficial. We have the support with A-GaME and MDOT's management. Also, stick funds can be used to defray state's cost for specialized equipment purchases. We are happy with the user-friendly CPT equipment and software, as we have started to use the CPT with remote training because of COVID-19 restrictions. We have seen a more detailed stratigraphy with CPT and improved production rates of about 2 to 4 times over SPT borings. With our self-anchoring CPT rig, the anchors typically pull out prior to running out of push force. Thank you for your time, and feel free to contact me with any questions.
Hello everyone, this is Desiree Douglas with the Alabama Department of Transportation, and I am the Assistant State Geotechnical Engineer. I will be talking about our use of geophysical methods for sinkhole exploration using electrical resistivity surveying methods. ALDOT partnered with Auburn University to investigate and monitor sinkhole activity, with specific interest lying in Alabama's karstic geology settings. This map shows a landslide on State Route 219, southeast of Tuscaloosa. The 2 survey lines were conducted parallel to previously drilled boreholes. The results show the water table and slide surface were not picked up. The survey does show 2 apparent geologic transitions. The soil survey resistivities were consistent with the boring logs soil data. This map shows a sinkhole of US Highway 82 in the same general location. There were also 2 survey lines conducted parallel to previously drilled boreholes. These surveys had to be conducted approximately 10 feet off the edge of pavement to avoid a concrete box culvert, as such structures skew the survey results. It must be noted some misfit data had to be deleted from these surveys to obtain a final model. Feature 1 shows high resistivity, possibly indicating raveling soils. Feature 2 shows a vertical discontinuity, possibly indicating a dip in the rock surface. Feature 3 shows a low resistivity area, possibly indicating fractured, saturated limestone. This is consistent with open voids found during the well drilling program. This could also indicate soils are being eroded. Further investigations are required to confirm these assumptions, however. Some of the challenges we have faced are Alabama's state purchasing laws make it very challenging to purchase equipment. And of course, training with the use of the equipment and data interpretation is hard to get scheduled. Also, the presence of utilities, structures, and certain topography make for unreliable surveys. Going forward, ALDOT and Auburn University hope to continue research surveys together. ALDOT still holds a learning curve with our recently purchased CPT equipment. ALDOT hopes to tie in the electrical resistivity surveying with other subsurface exploration methods. Our ultimate goal at ALDOT is to establish a database of information pertaining to Alabama's geology. I would like to thank everyone with Auburn University and ALDOT's geotechnical team in conducting this research. Thank you.
Hello. Caltrans is part of the implementation planning team for the Everyday Counts A-GaME project. In this presentation, I'll discuss our experience with the advanced geotechnical methods in exploration and how use of geophysics adds value to project design at Caltrans. Caltrans is an institutionalized user of many A-GaME technologies. Use of geophysical methods for geotechnical investigation is prescribed in the Caltrans Geotechnical Manual, both for evaluation of subsurface variability and for in situ material properties. We also engage in research and development of geophysical methods and participate in national engagement on the topic through different avenues, including the Everyday Counts program. The Geophysics and Geology branch provides a number of in-house services, including several A-GaME technologies: refraction and refraction tomography, surface wave inversion, surface resistivity, and optical and acoustic televiewers. The A-GaME technologies are a subset of the services we provide, but comprise a significant percentage of our work. Surface geophysical techniques are used to interpolate geologic data into unexplored areas. Where no test hole data exist, geophysical reconnaissance provides valuable data to guide the drilling program and to focus the scope of the investigation. Borehole geophysics measures physical properties from sources and receivers suspended in a borehole. These methods provide continuous measurement along the entire length of the borehole, augmenting discrete information obtained from more expensive lab analysis of cores. Because geophysical methods cover more area than drilling, they improve data coverage. The portability of the equipment improves accessibility and reduces environmental impacts. In addition, the methods allow in-situ measurement of many earth properties that are important for foundation design. For project design, geophysics improves our ability to understand and predict the behavior of earth materials. By acquiring geophysical data before drilling, we help guide the drilling program and allow focusing the geotechnical investigation to areas of greatest concern. That goes beyond the concept of saving money by reducing the number of drill holes or lab tests. It also improves our knowledge of the engineering properties of earth materials and their spatial variance. This information allows less conservative design, better cost estimating, and fewer surprises during construction. A more accurate portrayal of subsurface conditions with good prediction of engineering behavior results in better bids from construction contractors and aids the owner in defense against claims. So for project construction, geophysics gives us additional means to verify the quality and capacity of essential foundation elements. In conclusion, selective use of geophysics can yield significant cost savings and improve the quality of geotechnical investigations. At Caltrans, we realize cost savings and added value through our in-house application of routine geophysical services. I hope you found this brief presentation helpful. Please reach out if you have any further questions on our work.
My name is Michelle Mann, and I'm a geotechnical engineer with the New Mexico Department of Transportation. The title of my presentation is Cone Penetrometer Test for Design and Acceptance of a Ground Improvement Project. This presentation will provide a brief overview of how we use cone penetrometer testing for site characterization and establishing ground improvement acceptance criteria. This was a bridge rehabilitation project with the geotechnical scope focused on ground improvement to arrest or diminish settlement in the west bridge approach. We took a phased approach to site characterization, first using our standard auger borings and SPT, followed by 4 CPT pushes. We compared SPT, laboratory, and CPT data and generated recommendations for compaction grout densification. Since we generated a performance-based specification, we specified post-grouted SPT N60 equivalent values for the acceptance criteria. The project is located west of Los Lunas, New Mexico, about 40 minutes south of Albuquerque. The approach fields are on the order of 20 feet in height and are comprised of sands with some fine-grained clay and silt zones. Groundwater is in excess of 100 feet below grade. Here's our boring location plan showing the approximate boring and CPT locations. You can see from the photo that the CPT pushes were performed at the west approach embankment only, since distress was limited to this area. CPT soundings were advanced with a skid steer mounted S4 universal push system manufactured by Verticality ARA. The reaction force was provided by twin 12-inch helical anchors set at approximately 7 feet below ground surface. Due to the anchor requirements through the pavement surface, a lesson learned was the additional time on site, coordination efforts between all subcontractors, and additional fees associated with removal and patching of the HMA to accommodate the anchors. The table on the top lists the SPT and CPT results, pre-treated N60 values, and minimum post-treated N60 values for acceptance, and the bottom figure shows the limits of the compaction grouting operations. This slide is one example of a comparison of pre- and post-treated ground improvement CPT data. Again, we based our acceptance on the SPT N60 equivalent values. To quickly summarize, our geotechnical site characterization consisted of 2 borings and 4 CPT pushes. Exploration data was used to characterize embankment fill and generate recommendations to arrest or decrease the rate of settlement. Compaction grout densification extended to a depth of about 23 feet below existing site grades to address the loose fill zones in the embankment and about 3 to 4 feet in the foundation soils. The department generated a special provision for ground improvement and based acceptance criteria on CPT N60 equivalent values performed after the first phase of compaction grouting. Post-ground improvement CPT pushes show changes in the SPT N60 equivalent values and other measured parameters, but results were not what we or the contractor expected to see. As we drafted the special provision, we required the contractor to generate a remediation plan if the acceptance criteria wasn't met. As a result, the contractor generated the remediation plan for department approval, and all remedial efforts were performed at no additional cost to the department. Thank you for your attention. My contact information is below if you would like more information.
The WSDOT Geotechnical Office uses a variety of geophysical techniques to augment our traditional geotechnical field explorations. The REMI method uses an array of geophones and ambient noise to develop vertical shear wave profiles at sites such as the Talleyway Interchange, which was a soft soil site that lent itself well to this technique. Using equipment that fits in the back of a car, we're able to develop this vertical shear wave profile. Seismic refraction is a technique that we use often to interpolate between borings when we want to find the depth to a dense layer, such as at landslides. Using the same equipment that we use with the REMI method, with the addition of an energy source that's hooked up to our seismograph, the energy source is usually a sledgehammer or a Betsy gun, we're able to develop subsurface profiles showing the depth to dense layers and the seismic velocity of those layers. This fish barrier removal project required removing a lot of fill adjacent to this bridge in order to get rid of this fish barrier and replace it with a new bridge. In order to find depth to bedrock, we planned a series of seismic arrays using our in-house seismic refraction equipment and developed a nice 3D model showing the bedrock surface beneath the entire site. By importing the data from this model into various softwares, including Adobe, we were able to make this 3D model, which designers are able to use to cut cross-sections wherever they would like. On I-90 at Snoqualmie Pass, WSDOT is using a variety of A-GaME techniques. The new Catchies River Bridge will be installed on drilled shafts being socketed into an uneven bedrock surface. This required interpolating between borings to find the depth to the bedrock. We used seismic refraction to develop this profile. Electrical resistance tomography is often coupled with seismic refraction. This proposed large wall along the side of I-90 required interpolation between borings to find the depth to bedrock. Using a combination of techniques, we developed these profiles. WSDOT also uses optical and acoustic televiewer imaging, including at Snoqualmie Pass, where we're designing some new rock cuts along the side of I-90. The televiewer data is used to augment traditional discontinuity mapping. The optical portion of the data is used above groundwater, and the acoustic portion of the data is for below groundwater. The A-GaME reduces uncertainty and reduces risk.
Okay, thanks to all of our presenters. I'd like to express our appreciation to each of the 10 states for putting together those videos, as well as all of our colleagues at the FHWA divisions, our EDC5 champions, and certainly all of our state DOT partners. Well done, everybody, and we greatly appreciate that a lot of great work has been going on over the past summer, despite some hardships. So a look to the future. As Ben noted in his presentation, really the A-GaME initiatives for geotechnical site exploration provide a launching pad to a number of other types of benefits. We're looking to the improved site information for risk reduction, reliability, variability assessment, improving quality really throughout the geotechnical process, because it starts with good subsurface information. And then we can use that improved information throughout our design and analysis process to get better information to provide to other stakeholders and customers. And that really results in oftentimes accelerated delivery, overall lower project cost. And I think you saw in a number of those presentations that there really are some exciting developments in data visualization, which are making it much easier to collaborate internally with other functional areas and also externally to non-engineers. I think we're able through the A-GaME to really provide a lot of additional resources for education and process improvement to our state DOT partners and beyond. I think there's also a lot of great information out there for private sector and consulting, and certainly everybody that relies on geotechnical information. As I mentioned in my presentation, we're really looking forward to some additional partnering opportunities. The DIGS XML interchange standard is now a provisional AASHTO standard, so states are going to be able to implement that relatively easy in specifications. And Everyday Counts 6 with digital as-builts will help really revolutionize data collection. And since everything that we are building sits on something geotechnical, unless we're designing perhaps Navy vessels or dirigible Zeppelin satellites or something, we can see that the importance of the geotechnical information can follow along certainly with the built environment. So we're really looking to a lot of new benefits in terms of information, education, and resources. And with that, we have a few minutes left. I'm going to turn things back over to Silas Nichols, our moderator, for the rest of our time.
Okay, great. Thanks, Derrick. And I'll ask Ben to turn on his microphone so he can hear also. We had a couple questions come in during all of this, and I wanted to make sure and get to those. Before we get to those, there were a bunch of requests for the slides from the presentations, and we will make those available. It will not happen immediately. We're building out a website with a landing page for a bunch of different purposes here. It should be available shortly, and we will begin to archive just about everything that happens through this webinar series and for all other things that we're doing A-GaME related there. For technical questions, Ben, we had a few come in during your presentation. With the use of the televiewer, are you recommending the use of an inclinometer to assess the verticality of a borehole?
Yeah, so Tom, I think when orientations of this rock structure is important, say, and for a rock cut, and I'm sure there's other applications, not necessarily, that may not be critical for a foundation assessment if we're looking at rock mass characteristics. But when we're looking at the rock structure itself, I have talked with a few people who point out the fact that even though that we assume holes are vertical, they are typically not. And recognizing that fact, I would strongly encourage for those holes to be assessed with a caliper and making sure the verticality of that hole is assessed so that can be corrected. So yeah, absolutely. When it's critical, I think that needs to be done.
While you were talking, there was a message that came into the chat from William Dell. I'll read it as is. Deviation data can come directly out of the OTV ATV logging. We have had to use it for crosshole downhole seismic measurements. So there is some technology out there that can help us also. So.
Yeah. So yes, that's an excellent point. You don't need to do inclinometer type assessment. There are downhole methods that can provide that data.
Okay. Are optical and acoustical data collected simultaneously?
They certainly can be. And I think one of the presentations, maybe it was from WashDOT, pointed it out that so if we're in a hole that does not have, if it's dry or if it's clear water, the optical can actually provide valuable data. The acoustic is going to provide information on a sonic signal being bounced off the sidewall. So there's going to be the amplitude of the signal, and so you're going to get some indication of signal loss plus the speed, which that comes back to provide the discontinuities and the asperities in the sidewall. So that certainly will work in cloudy water. So it really depends on the conditions of the hole itself, what you can do. Very frequently, both are used if they can be.
Okay, great. An implementation question: what other federal agencies have adopted the EDC-5 A-GaME program? So other federal agencies that would be involved in infrastructure design and maintenance, and I know we do have a couple. So
yeah. So the one that comes to mind, first and foremost, the Army Corps is a partner with us on the A-GaME. And in fact, they have agreed to be presenters in some of the upcoming webinars. So look toward that on some of their applications. Silas, I don't know right off the top of my head of other, but there are local agencies certainly that have been, federal lands with us.
Well, that was the other one I was going to say.
Okay.
Our federal lands office is a federal agency. So.
Yep.
Well, and I think there are other groups too. When I worked for the Minnesota DOT, we had actually gotten some information from the Department of Energy, and they had used cone penetration testing on a number of projects, and I think the Navy had used it, but there it was also for kind of environmental applications with the fuel fluorescence detector and some other widgets on it. So there are a lot of A-GaME techniques that are in common use by other groups that need to figure out what's down in the ground.
Yep, and I have seen those presentations too. It's we've just not had the coordination, from this program, unless you guys have had other coordinations with federal agencies.
And there was
we're looking to do that.
And there's a note in the chat that the NRCS, which nuclear regulatory, I'm not sure, is using A-GaME for their small dams. So, so.
Very good.
So for both of you, there were a few presentations that discussed CPT and SPT comparison studies being performed by some states. Is this necessary to adopt CPT for design?
Derrick, you want to take it?
So I'll give you an analogy which you may or may not like. I regard sort of the CPT and the SPT as similarities between US customary units and SI and the metric system. So you can use CPT perfectly fine on its own. It has been used, starting out in the Netherlands when they originally did it and all across the world. So you don't need to back calculate or compare with anything. A lot of people feel more comfort in comparing it to something that they're familiar with, in the same way that they like to have the meter stick and the yardstick next to one another and say, oh, okay, this is kind of how it shakes out. And so in my experience, a lot of people have done, some boreholes with some cone soundings adjacent to them to get the feel for what the differences are and what it means to them. But they can be used entirely independently.
Okay, so we have 1 minute left. Let's get one more question in here. The resolution of geotechnical methods generally decreases with depth. Can you speak to this limitation?
Yeah, so that's just a practical reality. There are ways to increase that resolution in some of the methods. If it's the array type, if we're talking about electrical resistivity, the spacing of the electrodes themselves. There are a few, one method that comes to mind that's sort of cutting edge is full waveform inversion. This is where they're doing some forward modeling, and they're looking at the waveform, from all wave types, and modeling that, and using difference model and a Gaussian to compare the error that they're getting back. And when they do that, there was one specific project that I saw where they were looking for a abandoned underground mine at 60 feet deep. None of the other methods were able to really distinguish an anomaly there, but the full waveform inversion was successful at showing something there.
All right, and with that, we are a minute over time, so I guess I'll close it the same way I began it, with a football analogy. Keep matriculating that football forward, people. First downs lead to success. Get your A game on.
Yes,
and thank
sir.
you very
Game
much
on.
for joining us.
Cool.
Thank you,
Thanks,
everybody.
everyone.
Take care.
Yep. See you next week.